Video lesson, Scientific Revolution. Before we begin, you should have out some paper to take Cornell notes on, and also another set of paper to do your questions. If you'd like to do your questions within your Cornell notes, that's okay. Okay, so before we begin, just a reminder on how to set up our Cornell notes, because I think this is going to be really helpful as we do these video notes, so you can take whatever notes you'd like, as long as they're in this style and that you can go back and refer to them later. So the first thing that happens is you write your essential questions at the top of your paper. So our essential questions for today is: what is the scientific revolution? Who are the main contributors to the scientific revolution? And what advancements were made during this time? After you write down your essential questions, you can draw a line on your paper to show that that's where the notes begin. Then, as we go through the notes, you'll see the top of PowerPoint slides. It would be a good idea to change those into questions. So for instance, the first thing, what is the scientific revolution? And you can write this in your in the left-hand margin. If you need a little bit extra room, feel free to draw a line down your paper about an inch in from the left-hand margin. And then you can write your notes as we go about that topic question. Now, once the topic question changes, then you can write your second topic question, which for today's lesson would be something like, who is Galileo? And then you can write your notes for that as well. So take a minute and just set up your Cornell notes with your essential questions and get ready to write our first question, which is, what is the scientific revolution? So the warm-up question that you completed in class today is, what is a revolution and what revolutions can you think of? So I'll let you finish the answers to that question if you want to put them in your notes. Okay. What was the scientific revolution? This is our first left-hand margin topic category question. This was a revolution in thought. It was not a revolution in political control, as some of the examples that you might have thought of include things like the American Revolution. That was a revolution in political control. The American government wanted to overthrow the British Empire and the British Crown having control over them as a colony. They wanted to be independent. This is a scientific revolution, so it's a revolution in the way people think about the world around them. So it was a movement of scientific thought and inquiry. Inquiry is asking questions, and this scientific revolution changed the way people thought about the world. It was initiated in the mid-1500s to the 1700s in Europe. So think about the context that we put that in before you watch this video of the Renaissance and humanism and secularism. So continuing on with those notes, the scientific revolution questioned the nature of the world, society, and knowledge. So think about how influential the church was. So at this time, they started to think that maybe things should change as humanist and secularist thought shifted away from the ultra-religious, God is the only one who knows anything about the world and the only one who can find out. So the question that they constantly asked was, how do we know what we know? And this resulted in advancements in astronomy, chemistry, physics, and biology. Many of the principles that we base our sciences on today were founded in this time. So we're going to highlight a few specific scientists to just get us thinking about how important this time period was and how revolutionary these people and contributors were. So our next question will be, who were the main contributors? Or if you want to go scientist by scientist, you may do that as well on the left-hand side of your margin. Oh, one last bullet point here. This whole revolution, because it was a revolution, uprooted those widely held beliefs about the world. So your first checkpoint. Define the scientific revolution in your own words. Question number 2. prove this statement wrong. The scientific revolution of Europe was the first time humans had investigated science in the world. And then the next thing is a prediction. So, how will the scientific revolution affect society politically, socially, and economically? Predict the effects. And you can take as much time as you need on this checkpoint, and then you can continue playing the video. Our first scientist is Nicholas Copernicus. Historically, Europeans believed in geocentrism. Geo meaning Earth, centric meaning the center. So they believed that the sun rotates around the Earth. And Copernicus believed in heliocentrism. Helio, if you know the element helium, it's what the sun is made out of. Helio means anything to do with the sun. So this is the belief that the sun is the center of the solar system. And he observed this exclusively through individual observation, and this was helped by the telescope, which we're going to talk about in a second. But he proved this idea that the sun is the center of the solar system and the Earth rotates around the sun, not the other way around. He also discovered the daily rotation of the Earth on its axis and the revolution of the Earth around the sun. So the concept of a year and a day, those were scientifically proven by Copernicus, even though people had been believing in those things and living their lives by those sorts of calendars for thousands and thousands of years. Johannes Kepler. He was a mathematician, astronomer, and known for his laws of planetary motion. He confirmed Copernicus's heliocentric theory, and he also proved that planetary orbits are elliptical. So think of an ellipse, it's an egg shape, and they're not circular. They're more ovals. They don't perfectly go in a balanced circular orbit. In addition to this, he also identified and named 6 known planets other than Earth. So that's 7 out of the 9 that were discovered. And Kepler's scientific work served as the basis of Newton's discovery of gravity. Galileo Galilei, most commonly known as Galileo, is just his first name, but his last name is very similar. He was a physicist, mathematician, and engineer, and he is credited as the father of astronomy. He helped perfect the first telescope, so going back to that idea that our tools are important to what we can do. And so in turn, he provided the definitive proof for heliocentrism, that we could, with the telescope, track the stars throughout the year, track other planets throughout the year, and seeing as we all, it made more logical sense that the planets and the Earth went around the sun as opposed to the other way around. He also studied sound and its transmission and offered significant contributions to mathematical understanding of time. He also discovered that falling objects accelerate at a fixed and predictable rate. So if you drop a bowling ball and a baseball off a roof at the same time, they're going to fall in about the same amount of time. Weight or mass does not matter when it comes to gravity. So he did this by testing a ball and a feather off the Leaning Tower of Pisa. They fell at the same rate. Francis Bacon. He is credited as the inventor of the scientific method, which you know as question, hypothesis, experiment, results, conclusions. So he came up with the specific uniform techniques for investigating new phenomena and idea. And this also includes independent variable, dependent variable, numbers of trials. He also believed that science is established through systemized investigation. So, like the scientific method, very systematically exploring a question. Repeated trials, and then conclusions can then be generalized to specific scientific principles. So, after repeated trials, you find out that something is fact. It wasn't just coincidence, or it wasn't just that one time. You have to try something repetitively in order to reach a conclusion and to reach a scientific principle. Isaac Newton. He discovered the force of gravity. You might have an image of your head of the apple dropping on his head from a tree. Every object is attracted to every other object. And he created most of the laws of motion and universal gravitation that those of you who are in physics right now probably have heard his name and know his laws very well. Things like inertia, momentum. So he has 3 of them. 1, an object at rest will stay at rest. Objects in motion will stay in motion. So unless a force either moves an object from rest to motion or motion to rest, then that object will remain in that state. He also discovered force, mass times acceleration. He also discovered that for every action there is an opposite and equal reaction, not an object and equal reaction. There is an opposite and equal reaction. And he applied these laws of motion to planetary orbits, comets, tides, equinoxes, and he further proved the heliocentric theory that Earth rotates around the sun. The sun is much bigger than the Earth, so therefore the Earth would be the one attracted to the sun and pulled by the sun's gravity in an orbit. And that's how he also discovered other planets would follow that orbit, and that things like the moon would revolve around the Earth because the Earth has a greater mass than the moon. Checkpoint number 2, and then you're finished. What tools contributed to the scientific revolution? How did the scientists of the scientific revolution impact one another? And of the scientists discussed, who do you believe gave the most significant contributions to the scientific revolution? And here I want you to justify your reasoning. So prove which one was the most influential, or who gave the most significant contribution. And then you are done. So remember, at the end of our Cornell notes, we write a summary. So draw a line underneath all these notes and those questions, and then you can finish writing your summary for this section of the notes. Nice work.